Let me welcome you to the 10th lecture of NPTEL online certification course Network Analysis for Mines and Mineral Engineering. This lecture will be on example of slacks and calculation of slack for AON network. So, like every class, let us retrospect what we have covered in our previous lectures. In previous lectures, we discussed about the determination of identification of the slacks in the jobs, then calculation of the slacks, that slacks are possible only in those jobs which are not critical job, and we are able to now calculate slack from the early start, early finish, late start, late finish calculations, and we also know the algorithm for both the total slack and free slack, and we will discuss some example in this lecture, and we will calculate the slack for the activity on node network also. So, these are the two topics we will cover: slack calculation with activity on arrow diagram and slack calculation with activity on node diagram. So, for that let us consider the example. This example is also discussed in earlier classes, and you know we have directly come with the network where job A, job B, job C, job D, E, F, G, H, I, J, K. So, all these 11 activities are basically joined together to form the network, and their predecessors successors are well defined, and that is why the network is constructed, and these are the duration of those activities, and let us consider these are in hours. So, this activity network is complete, arrow diagram is made for this network, and our task is to calculate the early start, early finish and late start, late finish for carry it out further. So, you can see we are having available path 1, 2, 3, 4, 5. So, these 5 paths are available in this network, and in this 5 path you can see the path lengths are calculated 9 hours, 13 hours, 16 hours, 15 hours, 16 hours. So, the maximum path length 16 hours is the critical path, and we have also calculated the early start, early finish time for all the activities, and these are computed in this network. So, this is for kth job, this is for jth job, this is for h job, this is for f job. So, it is actually figure is little bit distorted, that is why it is looking like this. So, you can see the first consideration is the starting time is 0, considering that first job the early start times are considered as the 0 for A and B, the completion times are early completion times are considered calculated based on that. So, you know the formula, the earliest finish time, early finish time is equal to early start time plus the activity duration. So, using that formula we have computed early finish time also, and in the forward pass we have in forward calculation we have computed early start and early finish time as presented here under the third bracket. And again let me refresh you that early start time for a job X is the maximum is equal to the maximum of the early finish time of all its predecessors. That means, unless and until the predecessor jobs are finished, it cannot be started. So, earliest possible time starting time is the maximum of the early finish time of the predecessors. So, that is calculated in this network, and let us carry out the backward analysis also. So, in forward analysis we have found the critical path length is 16. So, that means the earliest possible time to finish the complete project is the 16 hour. So, that means, if the earliest starting time s is equal to 0, the earliest finish time of the project t is equal to 16 and the earliest possible finish time is the considering the 16 is considered as the target time, and backward calculation backward analysis is carried out for determining the late start and late finish for this network, and we have found these are given in this red color under the third bracket. So, the target date is 16, the earliest finish time is 16, and for addressing this target date we have to latest by this 16 we have to complete job k and job g. So, that the late finish time of these jobs are 16, and accordingly we have calculated the late start time is equal to late finish time minus the project job duration t. So, late finish time minus 1 is 15, 16 minus 4 is 12. So, that is the late start time we have achieved, and for the other predecessor jobs it is calculated like this. So, this is the late start time, or you can say the minimum of late start time of the successive job is equal to the late finish time of the job x. So, that is why you can see in this case there are two jobs, the late start time of this j job is 12, late finish time of late start time of job h is 7. So, the latest finish time of job f, which is the predecessors of that, is minimum of this, that means the 7. So, in backward calculation we have to consider the predecessor job, and that is why for this particular job we have to see which one is the minimum of the late start time of the successive activities, and considering that we determine this late start and late finish time. So, these are already discussed, and I believe that you are able to understand this. So, now at this point we are having job name, this is the job duration, and under bracket early start, early finish, under bracket late start, late finish. So, these are presented in all the jobs on their arrow. So, let us see, if we are looking at this, we can find out for job B, job E, job I and job K. So, job B, job E, job I and job K. These jobs are having their early start, early finish time, late start, late finish time same, late start, late finish time same. So, basically they are representing the critical job, and this network is basically representing the critical path. So, basically this job does not have any slack hours, and let us then calculate the slack hours for the other jobs in this network. So, you can see the slack hours are available with, these are, let me draw the critical one in red. So, this is the critical path. So, apart from this path, all the other activities are having some slacks. So, we are having slacks at A, at C, at D, at G, at F at H and at J. Okay. And using the algorithm which we have already discussed in our previous class, let us calculate the total slack for each activities. Say you can, if you find it out, total slack of A is equal to latest start of A minus earliest start of A, and obviously that should be equal to the late finish of A and early finish of A, and you can see it is calculated by 7 hours, either 7 minus 0 or 9 minus 2. So, this is 7 hours. So, similarly we can see for C it is 7 hour, for G it is 3 hour, for D it is 3 hour, for F it is 1 hour, for H it is 1 hour, and for J it is being calculated as 6 hour. So, these jobs are having a slack hours of total slack hours for each and every jobs are represented here. And if the slack is 0, that means the job is lying on the critical path, that is also known to us. Now, let us check for the free slack here. So, if you check for the free slack, you can find out the free slack associated with job A is equal to 2 minus 2, that is the total slack of A minus total slack of C, because C is the only successor of job A, that is coming to 0. Or in other calculation, the earliest starting time, if you are considering based on that, it also determined to be 0. So, that is why it is coming to this is earliest starting time, and this is the total slack minus total slack of A minus total slack of C is considered here, and this is coming 0. If you are considering for C, or let us check, let us consider it once more. Say we are having free slack of two formula. One is the minimum, or you can say earliest starting time of succeeding activities minus the early finish time of job X. So, if you are considering this, early finish job time of X is 2, minimum of early starting time of successive activities is 2. So, that means it is 2 minus 2, it is giving you 0. The second formula is the free slack of X is equal to total slack of X minus minimum of the total slack of all the successive activities. So, in this case the successive activities is only one C, and the C total slack is 7, total slack of A is also 7. So, it is 7 minus 7 is also 0. So, that means free slack for job A is 0. Applying the same rule while we are proceeding, we can see the free slack for job C is 4 hour, because the only successive job G is having a slack of 3 hour and the C is having 7 hour slack. So, the free slack available with job C is 4 hours. However, for job F it is 0, job D it is 0, but again H is having a free slack of 1 hour. So, that means we are having free slack at C, and at H, and in these two cases we can use these free hours as per our own wish, and we can carry out any maintenance etc. related work, though the activities in other part of the network is being carried out. So, these free hours can be easily utilized in these jobs. especially the manpower withdrawn is one very good option. Utilization of the manpower in other sector is one good option for the free slacks. So, this is one part we have covered. We have seen the calculation of total slack and free slack for the activity on arrow diagram, but so far we have not discussed anything on activity on node diagram, how you can compute that, because here the jobs are mentioned in the node. So, let us carry out one example. The example is of the same one which we have carried out, that the project budgeting example, and this is already given to you in this project budgeting. We can start, there is a start node and jobs are given in the nodes. So, these are the different jobs. So, that is why we are able to eliminate the dummy jobs in this case, and those jobs are given in the node, and this is the representative of that network. I am not giving you the details because it is already with you. So, the network is representing this problem. So, now let us look into the calculation of this. The early start, early finish calculated here are mentioned on the top of the job. So, if the node is there, we give the name comma time and the early start, early finish, early start, early finish, and if options are available, let start, let finish at lower part or maybe in the upper part with separated by a comma may be given in this case. So, this is the way we are presenting here. So, let us consider we start our job at 0. So, this is the S is equal to 0 here, and if it is we start at 0, it can be started at 0 time, will be ended at 3. So, while we are carrying out forward calculation, forward pass or forward calculation, we carry out the same principle where the early start of a first job is equal to S, it may be 0, it may be anything. So, most of the generally we consider it is 0. Then early start of a job is the maximum of early finish of all its predecessors x, and early finish is the early start of job x plus time of the x. So, this is 0. So, from 0 this is duration is requirement is 3. So, that is why the early start time is 0 here and early finish time is 3 here. For this job it is the early start time is 0 again, early finish time is 14. Then while we are considering this one, then it is the early start time is the maximum of the early finish time of this one and this one. So, maximum of 3 and 14 is 14. So, early start time is 14 here and completion time is 14 plus 3 is 17 here. So, this is the consideration. For here it is again 14, 14 plus 7 is 21, here it is 21, 21 plus 4 is 25, and for this case again we have to consider the maximum of this one and this one. So, maximum of 17 and 25 is 25. So, 25 is coming here as the early starting time plus 4 is 29 is the early finish time, and this is the end 29, 29 is the end. So, that means the T is equal to 29, S is equal to 0. With this consideration we have found the total activity, total network length is 29 and some paths are of different length, but the target time is 29 hours. So, the logics are also given, these are the logics, and these logics are as same as with the T with the same as the activity on arrow diagram, only these calculations are presented on the node, not on the arrow. So, that is why basically when we are carrying out computer analysis, computer based analysis, that time it is very easy to compute in activity on node diagram. The moment we place these activities as an array in the network, that can easily calculated based on the values of those array, corresponding values of those array as the early start, early finish, late start, late finish calculation. So, let us look into the early finish also. So, in consideration of, we have found the earliest finish time of the complete network is 29. So, T is considered as the 29. So, last job's latest finish possible time is 29. So, we have assigned this latest finish possible time is in the last job as 29, and then we have carried out the 29 minus the time. So, let finish minus time is giving us the late start time. So, 25 we have achieved at this position. Considering this is 25, we have having the algorithm like this, that latest finish time of this job is the minimum of the latest start time, of all its successor job is equal to the latest finish time of the particular job. So, that means, the latest finish time of this job is equal to the latest start time of this job. While we are considering this job, in that case the latest starting time we have to calculate, let us calculate it subsequently. So, that is why this is the 25 is coming at this position, 25 minus 4 is 21 at this position. This is the 21, 21 minus 7 is 14 as the latest start time. Let us consider this one also, the latest finish time is 25 as same as the latest start time, and the latest start time for this is 25 minus 3 is 22. So, for this job let us consider for this job the minimum of these two job, latest start time of these two job has to be considered as the latest finish time. So, 22 and 14, among that 14 is the minimum. So, 14 is the time which is considered as the latest possible finish time for this job, and so 14 minus 14 is coming 0 here. For this case the latest possible finish time is 22. So, we are considering it is 22, and this can be latest started by 19 hour at this position without deviating the target finish time. So, this is the algorithm, and we are able to understand this algorithm is as same as the activity on arrow diagram also. So, now let us calculate the total slack and free slack for this condition. You can see again the logics are same. Let start by early start time is giving us the total slack, or let finish by early minus early finish is giving us the total slack of the job. So, the slacks are also computed, slacks in the A and B are available, and these are the available. We have already calculated it for the others, and this is basically the critical path. This is the critical path. No slacks are available in this network, because all the slacks 14 minus 14, 21 minus 21 or 25 minus 25, whichever you will calculate, it will come to 0. So, that is why the total slacks are only available in this activity and this activity, and this has been found 19 and 8. And as the same logic we have used for the free slack, that is the minimum of earliest starting time of the immediate successors minus early finish time of that activity gives us the free slack, or the total slack of that activity minus minimum of the total slack of the immediate successors are giving us the free slack. So, 19 minus 8, 11 is the free slack as we have calculated by the formula 1. So, this part is used using this one, and this part is used using this formula. So, this is the activity on node diagram, which can be on which we can calculate the early start, early finish, late start, late finish, total slack and free slack. So, this is the way we can compute for the total slack and free slack for the activity on node diagram. This is one example which already given to your very early classes, the very big example where it is given to you for computations. So, for arrow diagram and activity on node diagram, I have given you the answer in the subsequent classes also, and these problems are taken from the Levy's book. This is a construction problem. So, if you compute the slacks for this one, I am having another better figure of this. So, if you see this one, the total slack is given in black pen, free slack is given in green ink, and these are the job durations. This is the early start, early finish. Red one is represented at the late start, late finish. So, basically we have achieved from the forward pass calculation, the 34 is the target days, 34th day is the target day to finish the complete activities, but say though it is the earliest possible time to complete these activities, 3 days relaxations are given to all. So, that is why the target date is considered as the 37 as it is given. So, as it is given, we have calculated and we have found we can start 3 days late. So, that is why the late starts are considering the target date of 37 in this case. So, basically 3 hour slack is available for all the cases. However, free slacks are available only with the limited cases like in these cases. So, all the total slacks are having 3 days available to them, but the only these 3 total slack 3 are basically representing the critical path. So, total slack 3 is basically representing the critical path. So, this is representing the critical path like this way, and all are other having the slack hour. So, in this case as 3 slack hour is already given in the target date. So, 3 slack hour is already available for the critical path jobs also. So, that is a project planning carried out for this big activity in this case, and it can be considered, and free slacks are only available with few of the jobs where you can have free slack and you can withdraw your manpower from those activities for temporary basis. So, this is the basically requirement of calculation of this total slack and free slack, and this is a very complex example given. This type of complex examples has to be solved in your as your home task, so that you can be very competent for these activities. So, let us understand the importance of this total slack. If total slack is 0, then scheduled start time is fixed in a section. If total slack is positive, section in charge can allow some discretion in setting start time, but must be within the slack period. That means, in your first example where you had 19 hours slack, but you must complete your first job within the 22 hours. In that case, you had the possibilities you can start maximum by 19th hour for that job, but suppose this section in charge and this section in charge is different, then this section in charge is having the flexibility of only 11 hours, which is the free slack available to that section in charge. If he is exceeding among the 19 total slack hours, if he is exceeding this free slack hour to 19 total slack hours, that means he is unable to start it within 11 hours, say he has started it 14 hours, then he must inform that to the subsequent section in charge, so that he must be ready to address that problem. But in no case this section in charge can exceed this 19 slack hours, because that will then create the problem of completion of the project on time. So, that is why this is very important. Section in charge has to decide, he has the liberty to play with the free slack, but he needs permission if he is exceeding the free slack and enjoying the total slack, then that must be subsequently informed to the subsequent in charge of the successive job. If the total slack is negative, section in charge has to deploy extra effort. Total slack can be negative if it is found that your target date, in the previous example we have found that target date was 37 days, not the 34 days. But suppose it has been told that your target date is 31 days, then it is already negative 3 days slack in everywhere. It is not slack, it is basically squeezing. So, you have to deploy additional manpower in those cases. If it is positive, one can decide, the section in charge can decide for maintenance, relieving the peak loads, shifting jobs, etc. And free slack is very important, because that is the liberty of the section in charges to utilize that hours as per his own requirement or own understanding. So, this is more or less all about the slacks calculations and slacks understanding. I hope you are able to understand the importance of the slack. So, importance of the starting date, importance of the completion date, target date, slack hours, early start, early finish, late start, late finish calculation must be understood by all of you. Then only you can enjoy the problems, you can enjoy the solving of this slack calculation, etc. Thank you.